All right, let's take a little road trip today, but not on any ordinary highway. We're going to travel along your body's most critical superhighway, that incredibly complex network of arteries and veins that keeps your head and neck running. Think of it as a high-stakes, high-speed delivery system for the most important command center you have, your brain. So, to kick things off, here's a quick question for you. Your brain, right? It's pretty light, only makes up about 2% of your total body weight. But for its tiny size, it is incredibly greedy. So take a guess. What percentage of the oxygen you're breathing in right now does your brain demand? The answer? A whopping 20%. Yup, 1/5 of all the oxygen you breathe goes straight to that 3-pound organ between your ears. And that is why the circulatory plumbing we're about to explore isn't just important, it's absolutely mission critical. So, that's what we're going to do in this explainer. We're going to follow the blood on its amazing round-trip journey. We'll start at the heart, travel all the way up that superhighway to the brain, and then follow it all the way back again. So, let's get going. Every great journey has to start somewhere. And for our blood supply, it all begins at the heart, the powerful pump that gets this whole road trip started. Right out of the heart, we hit the main distribution hub, the aortic arch. You can really think of it like a massive highway interchange. It immediately branches off into 3 main roads. You've got the brachiocephalic artery, which handles the right side of the head and the right arm. Then there's the left common carotid, which is making a beeline for the left side of the head. And finally, the left subclavian artery, which takes care of the left arm. Okay, so the blood has been dispatched from the heart. Now let's follow those delivery routes, the arteries, as they start making their way north up toward the head. So the main highway running up each side of your neck is the common carotid artery. For a little while, it's a pretty straight shot, but then it comes to this incredibly important fork in the road, where the blood has to decide on its final destination. And here is that split. The highway literally divides into 2 completely separate routes. The external carotid artery, you could say, takes the scenic route. It supplies all the external stuff, your face, scalp, your tongue. But the internal carotid artery, it has one job, and one job only. Get that precious oxygenated blood straight to the brain, no detour. Just to give you an idea of those scenic off-ramps, the external carotid branches off to feed really specific places. You've got the facial artery heading to your facial muscles, the lingual artery going to your tongue, the superficial temporal artery supplies your scalp, and the occipital artery takes care of the back of your head. It's this whole complex local delivery network. Okay, so now we're going to follow that other road, the internal carotid. We're in the express lane and we're arriving at its destination, which is, and I'm not exaggerating, an absolute masterpiece of biological engineering. It's called the Circle of Willis. The best way to think of it is as the brain's own personal traffic roundabout. Now, to really get how this roundabout works, you got to know one key term, anastomosis. It sounds fancy, but it's actually a pretty simple idea. It's just a cross-connection between channels, which allows flow to be rerouted if needed. It is the core principle that makes the Circle of Willis even possible. You know, the source material that we're drawing from for this calls it a beautiful thing, because it provides alternative or collateral channels for blood to flow through. And it truly is. This isn't just plumbing. This is smart, redundant, self-preserving plumbing. So where's all the blood for this roundabout coming from? Well, it's fed by 2 major sources. The lion's share, about 80%, comes from those internal carotid arteries we've been following. The other 20%, that comes from the vertebral arteries, which travel up through the spine. So you have 2 different highways merging into this one central hub. The circle itself is basically formed by a series of connecting vessels. You have arteries connecting the front to the back, and others connecting the left side to the right side. And all together, they link up the major arteries in the brain into one complete, continuous loop. So what's the whole point of this elaborate setup? Well, its purpose is just brilliant. It's a biological safety net. If one of the main arteries feeding the brain gets blocked for some reason, this circular system means blood can be rerouted from the other arteries to bypass the blockage. It is an ingenious design to prevent, a catastrophic power failure in the brain. Okay, so oxygen has been delivered. Mission accomplished. But now what? How does all the deoxygenated blood and waste products get back home? Well, it's time for the return journey, and that happens via the veins. The return trip starts in a pretty unique place. Instead of using typical veins right away, the brain uses something called dural sinuses. These are basically large channels that are formed within the dura mater. That's the tough protective lining around your brain. They act as the primary collection system for all the used blood. And the path out of the brain is incredibly systematic. It starts with blood collecting in this large superior sagittal sinus, which runs along the top of the brain. From there, it all pools at a junction called the confluence of sinuses. Next, it flows out sideways through the transverse sinuses. Then, it takes this sharp S-shaped turn into the sigmoid sinus before finally exiting the skull through the main drain pipe, the internal jugular vein. And hey, sound familiar? Just like we saw with the arteries, there's a split in the return routes too. You have the external jugular vein, which handles the surface-level stuff like the scalp and face, but the internal jugular vein, that's the deep, high-capacity pipeline. Its whole job is to drain the brain itself. It's the perfect counterpart to the internal carotid artery. All right, we are on the home stretch. This is the final leg of the journey. First, that internal jugular vein from the head merges with the subclavian vein coming from the arm. Together, they form the big brachiocephalic vein on each side. Then, the right and left brachiocephalic veins join together, and that creates the superior vena cava, this final, massive vessel that dumps all of that deoxygenated blood right back into the heart. And just like that, the circuit is complete. So when you put it all together, when you look at the whole trip, you see this just incredibly elegant and, of course, absolutely vital system. So what are the big takeaways from our journey? Well, first, remember the two roads. The arterial supply splits, one for the face and one for the brain. Second, the circle of Willis is the brain's genius protective roundabout. Third, the return trip starts in those unique collectors called dural sinuses. And finally, just remember that it's all one continuous, perfectly synchronized circuit from the heart to the head and back again. It really is an engineering marvel, isn't it? Designed with backups and all sorts of redundancies. But this incredible elegance also brings up a pretty critical question. What happens when a system this perfect actually fails? Well, that's a topic for another day. Thanks for joining this explainer.